In this last video, we're going to look at 44, 54, and 56. And in number 44, we are to graph the function in a viewing window that shows all of its x-intercepts and then approximate its zeros. The first thing I want you to do on this, even though this is a calculator problem pretty much from start to finish, before you use your calculator, I would like for you to look at your leading term and determine what you know about the function because of its leading term. And here we have a equals -1 and degree 3, or obviously you could also say cubic, but because of that fact, you know that it's going to follow the parent function, and in terms of its shape, it's going to be just like it, except for the fact that we have this -1 for a, which is going to take the standard cubic graph and turn it upside down. So the overall shape should look like that. Now, of course, this doesn't really tell us what's going to happen in the middle, but it does tell us what's going to happen in the end. We also know that because it's degree 3, that we have at most 2 extrema and at most 3 zeros. And that's important because when you're told to graph something, you need to know what you're looking for to know that you've got all the significant information in the picture that you're looking at. So obviously you've got the picture in front of you from the study guide, and this is the graph that's on your study guide as well. So when you trace those values, and that's how you should go about, even when it says approximate, you can actually use your calculator. And when you use trace or calculate on your calculator, in essence what you're getting is an approximation unless in its exact zero. And we know these are not exact zeros because they don't even hit on the 0.5 marks on the x-axis. So when you trace these values out, and I would like for you to pause the video and do that for yourself and then come back and check it. And what you should have gotten is for this first zero, you should have gotten that x is approximately -1.73. And then for the first positive zero, you should have gotten that x is approximately 0.259. And then for your third and final zero over here, you should have gotten that x is approximately 4.47. And that's all you have to do for that one. In the last two, you're going to be given zeros, and you're using only algebra. You are to find a cubic function with the given zeros. And then you are to support by graphing your answer. So you start by thinking backwards from the fact that now we have the answers, so what were the factors? So the function we're going to write, and you're going to keep it simple, this is what you do. A factor that would have a zero of x of -2 would be x plus 2. A factor that would have a zero of 3 would be x minus 3. And a factor that would have a zero of -5 would be x plus 5. And in this factored form, you immediately could see where the zeros would be. But we want to write this in standard form. And to do that, we're going to save this x plus 2 for last. And if we were to multiply x minus 3 times x plus 5, we should get x squared plus 2x minus 15. And then we have to distribute the x. And notice how I'm going to do this. I'm going to distribute the x in the x plus 2 to the trinomial, and then I'm going to come back and distribute the 2, but watch how I write it to make it simpler. And this is to save you from silly little mistakes to keep you from getting the right answer. If I distribute the x, I get x cubed plus 2x squared minus 15x. And now I'm going to distribute the 2, and if I distribute 2 onto my trinomial, I get plus 2x squared, and I'm going to start it so that it lines up with its like term above it. And then 2 times 2x is plus 4x, and then 2 times minus 15 would be minus 30. And it's the only constant, as x cubed is the only cubic. So our final form of our polynomial is f of x equals x cubed plus 4x squared And then minus 15x plus 4x would be minus 11x, and then minus 30. And that final form is what you should graph, and then check your zeros to make sure that you get back what you were supposed to get. That one was not too bad, and now we go to number 56. And when you look at the zeros, you can probably figure out why I wanted to do this one with you as well. Again, you'll start off by writing the factor that would give us a 0 of 1, which would be x minus 1, and then a factor that would give us a 0 of 1 plus the square root of 2. Now watch carefully how I do this. You have to have the 1 plus the square root of 2 in parentheses, in the same way that to show the factor for the 0, 1, I had to reverse the sign. Writing x minus and then putting that in parentheses takes care of that same effect. So then the final factor is x minus, and then in parentheses 1 minus the square root of 2. So there's my factored form, and now we will again expand. So we keep the x minus 1, and then we FOIL what we have here. So x times x is x squared. So that was this term times this term. And now I'm going to do x times this little binomial over here. So I'm going to have minus 1 minus the square root of 2x. And then I'm going to, if you're thinking foiling, my inner product would be minus, because now I'm multiplying this term times this x. So this is minus 1 plus the square root of 2, close parentheses, x. And then finally, plus, and I've got plenty of room to write this in case you were thinking I was running out of room, because I'm going to approach this from the standpoint that this is really, let's see if I can write this in a different color so I can write it right on top of what we're doing. This is going to be like my a plus b, and this is like my a minus b. And if you have trouble processing what's about to happen, pause the video and do this on your study guide over to the side. So then remember, a plus b times a minus b is a squared minus b squared. So this is 1 minus the square root of 2 squared would be 2, is all that's left from that one. And then I'm going to combine my like terms from that hideous result on that polynomial with all those crazy numbers in it. And x squared is the only square term, so I will keep the x squared, and then I will go term by term to take care of the rest of it. So we've got x squared, and then again I'll switch colors to do the little scratch work to show where all the stuff that I'm about to write is coming from. I've got, I'm taking minus 1 times x. In fact, no, I'm going to stay in purple and just write it. So minus x, and then I've got to do minus square root of 2x, so that would be plus the square root of 2x, and be very careful how you write that, so there's obviously x's outside the root. And then I've got a minus in front of this 1 plus the square root of 2, so I'm going to do the minus 1 times x, so that's minus x, and then minus the square root of 2x, and then I'm going to come down here and add this constant, but hang on a second, we can actually just make that plus, because this would be plus negative 1, so we're just going to make it minus 1. And we're not through cleaning up yet before we go to our final step. So we've got x minus 1, keep the x squared, and then I've got a minus x and a minus x, so that's minus 2x, and then it's really lovely, but here goes these two canceling each other out, so I'm through with that radical, and then I've got the minus 1. And then this becomes the same little setup we had earlier on the previous problem. When I distribute the x, I get x cubed minus 2x squared, wait, that's a square, and then minus x, and now I'm going to distribute the negative 1. So I'm going to write that so that I'll line up with my like terms. So that's minus 1x squared, and then plus 2x, and then plus 1. And then when I combine my like terms, I get my final polynomial. So I get f of x equals, and we'll do this like a little answer box down here, x cubed, and then minus 2x squared minus 1x squared would be minus 3x squared, and then minus 1x plus 2x would be plus x, and then plus 1. And that is the end of this example and all of your examples for 2-3.